In assignment 1 of structural optimization and 3D printing, I have been working to generate a simple bridge structure from scratch. My bridge is set to replace the existing bridge where Church Street passes over the CityLink toll road in Richmond, Melbourne. To start my assignment, I had to determine the domain my design was required to fit within. Based on my student number, this was the limiting 2D profile of the right half of my bridge. It also required a total supporting width of 9.64 meters and a 3.5 meter area underneath the bridge to be left for vehicles on the CityLink road to pass under. The first method for generating an optimized structure from this design domain was manual optimization using Abacus. To achieve the required volume in 3 iterations, 1/3 of the excess volume needed to be removed each step. This is the first Abacus diagram of the internal stresses in the design domain under the loading specified by the design requirements. The grey areas are under the least stress and are removed to create the first iteration of the optimization process. This is then repeated to remove approximately enough each time to reach the final required volume after 3 iterations. The other optimization method used the BESO Matlab code to generate an optimized structure from the same design domain. This method used far more steps than the manual method and generated a number of optimal designs. Merits. This was the final design, which was selected for being the most load-resisting structure with the least deflection and the best stress distribution. The volume is the same as the existing bridge's supporting substructure, despite having a 2.41 times greater width. Here I demonstrate the bridge's ability to resist deflection under an 800 kN point load on the center, and here is a figure depicting the structure's impressive ability to distribute internal stresses under the required uniform surface pressure. This structure was the best optimized design created, so here is the whole bridge rendered into place at Church Street. My feelings from this project are quite mixed. I found the content from the first term was actually really interesting and could easily be applied to the real world. There are so many instances in engineering where optimal designs are necessary for innumerable different reasons. The assignment, exploring methods of optimizing from scratch, is really insightful. On the flip side, a large portion of the criteria for this assignment was relating to professional analysis and presentation. This alone is fantastic, as it develops students' professional skills, but the documentation and requirements were so unprofessionally presented that it was extremely difficult to learn anything. Assignment 1 was really let down by this. If there was a single document with everything set out in a more professional structure, I would have found Assignment 1 to be far more beneficial to me as a student. The level of disorganization from the requirements for Assignment 1 has left me with low expectations for future assignments. I understand that it's easier to use various assignment documentation from previous years, but multiple assignment materials with different information all trying to address what's expected for Assignment 1 is unprofessional and, from a learning standpoint, unacceptable. The minimum I expect for future assignments is a single, clear, finalized document outlining the process that is expected. Of course, if questions are posted, answers can come separately, but the level of disorganization from Assignment 1 was quite disappointing. Thank you for listening.